Alrighty. I think now is a good time to get started. So thanks everyone for coming today. Today we're going to be going through submitting a article to SciPy Proceedings in 2024. And so this is the author overview, and the types of things that we are going to go over today are the overview of the proceedings, because there have been a number of changes since 2023, and the new submission process. And then we're going to go through some questions and demos. So I am Rowan Pockets. I am the CEO and co-founder of Curvenote. And I'm also on the SciPy Proceedings committee as an editor, and working on this process behind the scenes with a team of people there. And I'm also on the executable books team, which is the project behind MyST Markdown that we'll talk about a little bit today. So some of the objectives that we're going to go through today are just sort of the overview of proceedings and some of the background of where we're trying to move these proceedings over time. We're going to talk about the submission process in detail, and then go over any questions that the folks on the call today have, and sort of where we can point you to get help and other places and resources for that, as well as any live demos that we can see as well at the end. Just a note that this event is being recorded. There's some of you who are seeing the recording on YouTube, and then there's some who are in the Zoom call directly. If you are in the Zoom call, please do mute your microphone when you're not speaking, and raise your hand or use the chat. And I'm here with Franklin, who's monitoring the chat as well and can respond to some questions. Okay, so I'm gonna start with sort of a slide of science, a caricature of science communication today, as sort of a two-column PDF with a table of data on its side that you're trying to look at on your phone. And it doesn't support data well, it doesn't support interactivity, it doesn't support computation, and it's really not built for the way that SciPy researchers work and create their content and their software. And we want to do the best we can in supporting that work. And so these are the types of things that the SciPy Proceedings Committee was thinking about in 2023 on how to sort of radically improve and transform the proceedings that you're seeing on the screen here, which is primarily oriented around a PDF document. And they wanted to see how they could improve the proceedings to live up to some of the ideals of interactivity and supporting next generation computation like Jupyter Notebooks and integrating live computation into a journal. And so that is some of the things that we'll be going through today and talking about how the proceedings are looking in 2024. And this is in part sponsored by Curvenote, which is the company that I work for. We're a gold sponsor of SciPy 2024 and the Curvenote, or the SciPy Proceedings. And so we're helping out with some of these ideas. And again, we want to be able to go from this sort of caricature of science communication stuck in a PDF document to a different idea of much more interactive, computational, interactive communication that is more aligned with the scientific Python community. And that really gives us a chance to redesign science communication to better match how we're working in software and using some of the capabilities of the Python ecosystem to enhance reproducibility, interactivity, as well as the reading experience. So what if we could explore results instead of having a single static figure? What if we could dive into footnotes, references, citations with videos, and just sort of keep on diving down until we find the methods, the data, and the code? And what if we could push a button and spin up some of the computational environments in the cloud to reproduce and visualize the work and run new physics simulations with new data? And these are the types of things that we're thinking about when we're designing and redesigning the scientific proceedings this year, is pointing in this direction to be able to sort of improve the scientific record in a way that supports the process of doing science, that idea of standing on the shoulders of giants, where you can take someone else's idea and fork it and really see all of that reproducible work and bring it together. And that is the ethos of SciPy as a conference, is to showcase the scientific Python ecosystem, to learn from each other, and to collaborate really well. And so it's in that direction that the SciPy Proceedings is starting to move. And in 2024, we had a complete redesign of the Scientific Proceedings website. And that is a visual redesign, and it is moving towards web-first articles. And so this is one of those web-first articles from 2023 that is going through, and you can see all sorts of metadata and listings on this page. It's mobile friendly, and it has some of these features of deep dive links and hover references. And so, for example, this is one of the 2023 papers where you can hover over any reference in that, any cross-reference in that paper, and actually see the figure directly. And that is also the case for things like abbreviations, like EEG and fMRI, in this case, being able to hover over those and see those abbreviations directly in line. And we are, after all, a scientific Python conference. And so bringing in ideas like linking out to GitHub pull requests and seeing previews directly, and issues, as well as actually the code if you're referencing directly on GitHub. We're bringing in a whole new way of using dark mode, and instead of in a PDF document where it's very difficult to copy code, you can actually have a copy code button directly in the reader. And we can still have those PDF documents. And so there's a new template that we're working on for the scientific proceedings for 2024 that will look something like this. However, all of the work that is going into this is around that web-based first experience. Fantastic. So that's a bit of an overview of the scientific proceedings and where that sits today. And I want to go through the workflow that an author will go through when submitting a proceedings article in 2024. And so very briefly, the process is centered around MyST Markdown. So that's mystmd.org, which is some of you might be familiar with the roots of this in tools like JupyterBook or the integrations to the Sphinx ecosystem and the sort of roots in the restructured text markup language. And so MyST is markedly structured text. And so it's a markdown variant that adds syntactic flavor on top of common markdown to bring references and those cross references as well as interactive figures to life. And so we'll walk through that in some detail today and give you an idea of the flavor of the markdown. In addition to MyST, we are also supporting LaTeX this year, as well as we did last year. And so you can write your draft either in MyST Markdown or in LaTeX. And a note on the LaTeX is this isn't a full LaTeX environment, so there are many macros and custom environments that may not be supported. And so we definitely recommend the MyST way of working, but if you are more comfortable in LaTeX, we will support that as much as we can, and you'll likely be in some conversations with the editorial team at SciPy to help support some of the features that you're looking to do. And so we will, in this webinar today, we'll walk through a couple of those templates and look at the various structures of them and how to get started from that. And then the process of actually submitting a proceedings article to SciPy is this exactly the same as last year, if you're familiar with that, is it's a completely open peer review that is done and facilitated through GitHub. And so any author will fork the 2024 branch of the SciPy Proceedings website, copy one of these documents into a new folder, and then start working from there, and eventually open a PR when that is ready. At the end of the month in May, the first draft is sort of ready for review. And then that review is, that is an automatic preview is created with some checks on there. And that is done through GitHub, GitHub comment and GitHub actions. And then the peer review process starts in earnest with both detailed comments in the pull request as well as summary comments. And then there's an iteration until the reviewers and editors are happy and the author has likely made some changes or improvements to their work. And then that is accepted and a PDF is created at that point and a DOI as well. So that is an overview of the workflow that we'll be going through today and that you'll be going through as authors for the proceedings. And I'm going to now walk through and talk a little bit about the MyST Markdown project. And so MyST Markdown is it's a markup language as well as a specification, and it's an open source community-driven effort to bring many of these features that we were outlining in terms of integrating interactivity and computation into the way that science is communicated. This is a community-driven effort around those ideas. And the ethos of MyST is this sort of idea of structured data where you can write your content once, either in these LaTeX documents or actually in the MyST Markdown syntax or in Jupyter notebooks. And then you can reuse those, export them to websites and journals, or you can export them to any sort of PDF template. And again, the SciPy Proceedings template will be completed at the end of the submission. And this is all facilitated by this idea of sort of structured data. Behind the scenes of this is that we're parsing all of this markdown into machine readable metadata and content. MyST Markdown is built on top of, it's a superset of Markdown. And so if you're familiar with Markdown, there are many sorts of syntaxes that are already in this text-based format. So you can do things like headings with these hashes or italics and bolds and lists and block quotes, as well as math, for example, as well. And this, of course, gives you a preview that you can do. And when we're starting to move to sort of these more complicated ways of working, we're going to have to say figure one and actually write that one in and say see figure one. And there's none of that sort of cross-linking between where you reference the equation and the content that you are targeting to reference, as well as there's limited support in Common Markdown for citations. And so these are the types of things that MyST starts to bring to the equation, or to the mix, I suppose. So this is that same sort of content that's written in MyST Markdown. So it's very, very similar to Markdown. Again, it's a superset of Markdown. And you can see exactly the same inline math. But then when we're starting to create these math blocks, we have this specialized directive syntax that starts with these triple backticks and then declaring the environment that you're working with. And so in this case, this is a math environment, and that comes with some capabilities. And in this case, labeling any sort of directive is one of those capabilities. And so this is markup that you would write in LaTeX as normal. And then you can label that content and then refer to it in a later time. And so this is, again, a figure directive that takes the source of the figure as an argument. And then we have some of these properties that we can set on this figure directive, including the name, the alignment, and the width, and then a caption for that figure. And then that is can be referred to in the same way for either a math block or a figure block as this sort of at syntax directly in the paper. And that is exactly the same as for citations. And so with citations, you can either do the at syntax and provide a bibtec file that's next to your document. And that key is what brings that content together. Or you can just link to a DOI directly, and that bibtec file will be auto-created for you. And so this content taken together allows you to have those hover previews and those cross-references and sort of bringing all of that metadata together. Awesome. So in this sort of workflow, that's an overview of MyST. And to actually get started in writing the draft, you're going to have to install both MyST Markdown, MySTMD, and Node.js locally. And to do that, you pip install MySTMD. And that also it is required that you need to have Node.js installed as well, because this is dealing with a lot of web technologies. And so that is also a requirement. And so if you go to nodejs.org and click the big green button there, you can get set up pretty fast with the latest version of Node.js. And to actually get the content for the two templates that we're providing this year, we have the GitHub repository here, github.com, SciPy-conference, and then SciPy Proceedings as the repository. And the default branch of that is already the 2024 branch. And so you can click fork on the GitHub interface and bring that into your personal space and start to work there. And then over the coming months, you'll open a pull request back to that main repository, and that's when the peer review will take place. There are, as I mentioned before, two templates that are the starting content for the SciPy 2024 proceedings. And there is one template that is built in MyST Markdown and one in LaTeX. Both of these are built with the MySTMD command line tool. And inside of these templates, you'll see that there's a couple images there. This main.md is the main Markdown file. The main.tech for the tech template is the main tech file. That is where you'll be writing all of your content. There are bibliography files, so that is that bibtec, which includes common references actually in the SciPy ecosystem already. And that is also exactly the same in the LaTeX side. So the main difference between these is either you're writing in main.tech or main.md. And then this last file is the mys.yaml file. And that includes all of the author affiliation and other types of metadata for your article directly. And so to get started with one of these, pick a path. We suggest the MyST Markdown path. That is the most widely supported path. And then the LaTeX, the types of content in this is about the breadth that you will be able to get out of the LaTeX side. And so if you are using LaTeX, keep in mind, SciPy is a web-first journal. We have support for basic packages in the LaTeX ecosystem. There are no custom libraries that are supported out of the box. And there is very minimal macro support at this stage. And it does use MySTMD for the parse and the render so that we can get out that consistent web-based experience, which is where the review is actually going to take place. And so please do keep that in mind if you're choosing the LaTeX path in here. This should be chosen if you're already very familiar with LaTeX, and if you're just getting started, we recommend the MyST Markdown path. Awesome. So that final file in those two templates is the MyST YAML file. And so this has all of the metadata for your project. And so you can see that there's authors and there's affiliations. And if you have an ORCID, please do include it, as well as your various affiliations. There needs to be at least one valid email for a corresponding author that is included. And then you can include a number of keywords for your project, as well as those abbreviations that you're using throughout your project. And so that is what enables those hover references or hover previews on the abbreviations. The one other piece that's important when you copy your template is to actually change this ID. And so if you read the comments here, keep it to SciPy-2024-your folder. And so as you copy that template out, put it in your own folder. You should only be making changes inside of that folder. And so if you have images, keep them inside of there. And that just allows no merge conflicts to happen when you're actually bringing that together. And this should have the syntax of sort of first name, surname, or something that's unique to your collaboration. So to get started with MyST, after you pip install mystmd and install node, you will change your current working directory cd into that author folder, and then type myst start. And that will do a couple of things. That will clone the template. So this is, again, choosing which template you're going to go into. You'll go into your author folder after you copy that, and then say myst start. And that will parse your project. And the first time this runs, it will query a template for you locally and install some libraries, and then bring up a local web server that you can use to preview your changes. And then at that point, any changes that you make locally will be shown up in the live preview. A few milliseconds later, it'll reparse the project, show you those changes, and you can use that as your ongoing preview for your content. And so that should be a relatively smooth way to work through this. You can see that that's pulling together the abstract. You're seeing a lot of different content in here that is in the template, including tables, equations, images, and the references and cross-references between all of your various elements. The next stage in this is to actually open a pull request. So once you're done a complete draft of your paper that is ready for peer review, you can open a paper colon pull request, and there will be instructions when you do that through the GitHub user interface to just put paper at the top and then put the name of your paper. And that will begin the process of interacting with the editors. And by that, I mean the SciPy Proceedings editorial team, who will take a look over your paper and then start assigning editors to your paper. As that's happening, GitHub Actions are run on every commit to the repository. And so this will look at your paper folder and give you a preview of the paper that's very similar to the one that you're looking at locally, as well as it will run a number of automated checks around the metadata for your paper, as well as the length of your paper. And it will give you these two links that you can click. And so that first one is a preview link that will just show you sort of where that came from. And then if you click that preview button, that will give you this page, which actually shows the full preview online. And this is what will be used for peer review. Again, all of the peer review in 2024 is on the HTML only side, and the PDF is not made until the paper is accepted. The other link in this GitHub comment is to this list of checks. And those are structural and metadata checks that are run against your paper specifically. And so those are things like the authors, is there a corresponding author? Is your abstract the sort of a certain number of characters, as well as the word count of your entire paper is under 6,500 words. And then metadata checks like asking you to include an an ORCID ID for your author. So this is a unique identifier for scientific researchers that is free to use and is commonly used to sort of track contributions across the scientific ecosystem. And we also encourage you to put down any credit roles for the authorship that might be there. So that's things like conceptualization, programming, data visualization, and things like that, if you're giving sort of specific callouts to authors who are doing various parts of the work. And then the big piece that will likely require a little bit of back and forth with this is to run some DOI checks on your references. And so that will ask you to include a valid DOI with every single one of your BibTeX references. We do know that some of your references won't have DOIs. In previous years, people have linked to things like GitHub comments or web pages, and those don't have DOIs associated with them. And so if that is the case, there's a place that's documented in the MyST YAML that you can comment those out and explicitly say that those are DOIs without, or those are references without DOIs. Awesome. And then at that stage, you've submitted a pull request to the 2024 branch of the SciPy Proceedings GitHub repository. And this preview will be made, and then we will start to enter peer review. And at that stage, the editorial team will assign peer reviewers from the scientific Python ecosystem who will go into detailed commentary on your paper. And we ask that you respond to that directly on GitHub to facilitate that peer review process. And that may go through a few iterations. And then there will be an editorial recommendation. And we hope that that goes through acceptance. And at that point, a PDF and a DOI are created. And so as I look at the peer review process from previous years, this is, again, all done through GitHub comments, is that you have these sort of review features directly in GitHub where you can have some high-level commentary, as well as actually quite detailed comments directly on the content. And that goes from everything from actually looking at the figures or down to words and grammars. But because it's done through this interface, that is actually quite a collaborative process going through it. And so throughout this process, responding, updating, and iterating, and you'll be asked and sort of prompted by the editorial team to do that and sort of when to do that. And then every time you commit to the GitHub pull request, a preview will be made and updated of your content. And then that will also go through the check system as well. Awesome. And then at the end of that, shortly before the SciPy conference in person, there will be an editorial decision to accept your paper. And at that point, we'll be sort of on the other side of that and be creating those PDFs and DOIs directly. And that is sort of where the full circle comes back to on this entire experience, is that PDF is created, the DOI is minted, and hearty congrats is given. And so we are Super excited to have everybody here today. Yeah, hopefully submitting an article to this year's SciPy Proceedings. The entire editorial team is here to help you through the process, and there's a technical staff as well from Curvenote that can answer any questions as you start to open pull requests or have comments on or questions around the LaTeX or MyST authoring experience. And so with that, I'm going to wrap up sort of the official webinar portion, and I will open it up to questions from the audience here. So thank you very much, and I'll turn the live recording off at this stage. Awesome. So I'm happy to show any demos or dive into anything else for the folks on the call today. So there's only about 4 or around maybe less than 10 of us. And so if anyone does want to ask any questions, feel free. I prompt Alan to ask any questions to get us started. Okay, so there's a question in the chat. So do you prefer us creating a unique branch for the pull request, or a new folder on the main branch is good? So as you fork the repository into your personal side, you will have to create a branch on that side, and then when the pull request comes in, you'll be working inside of the papers folder, inside of a folder in there, and that's when you're merging back in. And so that is on your own unique branch, yes.
I have a question, Rowan.
Yeah.
As you submit new commits and you get your live site builds, is it also building the PDF as well for you to just kind of keep an eye on, even though that's not part of the review process?
No, as the editorial team in previous years, a lot of the back and forth between the reviewers and the editors and the authors was around that formatting step, and sort of like trying to make sure that like figures were the right width, or the Python formatting was off on this part of the code, and that was taking a lot of authors' time. And so this year we tried to cut out as much as possible and just focus on the content of the manuscript. And we will make those PDFs and get it out to your approval, to the author's approval, after the fact when it's actually approved. And so there will be sort of a final step in getting back in touch and sort of looking over that final draft, which is quite similar to how other journals do that sort of final typesetting piece.
Nice.
I have a question. In terms of like reproduction, are these papers expected to have like full reproduction of results, or maybe just some sort of smaller demo of whatever library or whatever sort of advancement we've come up with? And how are you handling the sort of reproducibility aspect of the contributions here? Because some contributions obviously might be for like very large data sets, and like how is that being I guess what are your advice on that?
So this year we are the scientific proceedings committee decided to not sort of fully embrace computational reproducibility. So we are only supporting those Markdown documents and LaTeX documents. So that doesn't include any computational reproducibility at all. In the notes on the README, there is a section that says if you are interested in doing that, we would love to explore that with you this year. And so that's sort of a case-by-case basis, is if you think your paper would benefit from sort of some computational reproducibility or including notebooks, that is something that this system is capable of. But we still have a lot of questions on the types of things that you raised in terms of how to best do that, as well as how to support that in the review process. And so that's something that we'd like to experiment with this year in sort of a case-by-case basis. And so if you are interested in that, or if anybody on the call is, please get in touch and sort of flag that as maybe early in the process.
Thank you.
Any other questions? Okay, well, I think then we will leave it there and finish up a few minutes early. Well, maybe I'll offer to folks on the call. I have some live demos that are on my other screen. Is it worth going through any of that today, or is that something that people would like to see? Yes. Okay. Blaine says yes. Okay. So this is the sorry, I'll just ensure that I'm in a good demo headspace. So this is the two folders directly in the yeah, okay, that's a great idea. Thank you. Awesome. Okay, I'm going to jump into a couple live demos of MyST, and this is both the LaTeX template and the MyST Markdown template. And so in here we have these two templates in the papers folder, and I'm going to jump into the MyST MD template at this stage. And so if I'm already in that folder, so you are going to have to cd into that folder. You're going to pip install MyST MD. I have already done that. If you don't have Node.js installed, go to nodejs.org and click the button on the home screen, which will get you the install instructions for your platform. And then in this folder, we have this MyST file, which I talked a little bit about in the presentation. We have our bibtech folder, or our bibtech file, sorry, with a couple of different references. And so when you're copying this over, these references may actually be helpful to you as you're writing your paper. So there's Jupyter and Matplotlib, NumPy, Pandas, SciPy, which maybe is a hopefully helpful one. And then we have the main Markdown file, which has our title and abstract in it as well. And so the first thing that I'm going to do is say MyST start. And this is going to parse the project and then give me a theme up. And so if we go over to localhost 3000, just by clicking that link, then we can actually see this side by side. I'm just going to hide my sidebar for right now. And so we can see this, as you might expect, this title is coming over here. All of the front matter information is coming directly from our MyST YAML. And so we have our list of authors over here. And if we click on this, we can see email and ORCID ID and various affiliations that are associated with that, as well as keywords are coming directly from your MyST YAML. And then as you are changing this, if I hit save over here, those changes are showing up immediately on the right-hand side. And so we can make changes on this side and have them show up directly. And then that is entirely based on the content itself. And there's a couple of different things in this paper. So we have some introductory text to start with, and then some instructions directly that are tailored in each template. So these are slightly different instructions just for the format between the MyST Markdown template and the LaTeX template. So if we go into the bibliography section, we can see that we're using pandoc style citations here with this sort of open square brackets with the @ sign and then the DOI directly. And what this means if you're using DOIs is that you don't even need a citation. You can actually just go to any sort of DOI citation. So let's see if I have this sort of citation over here, and I can say @UI/this. And if I hit save there, that will actually bring in that cross-reference directly. And so there's no reason even to do anything other than copy the DOI in if it has a DOI. So that brings all of those cross-references in, as well as down at the bottom, it will show you the references section. And so that's much better than writing out APA formatted something by hand. And so that hopefully will save you a lot of time when you're using this format. And there's a couple different ways to format your citations. Again, you can add them into this directly with a semicolon there. What did I do wrong? This comma. That's very strange. Okay, I'm not quite sure what's going on there. Yeah, so you can start to bring your citations directly in there, as well as use keys directly into your bibtec file. And so if we go over to the mybib in the MyST template, this reference here, if you're familiar with bibtec, this is something that can be quite easily created through any sort of modern reference manager, like Zotero, for example. You can export your bibliography as a bib file and then copy the text into there and then just reference that key. And that, again, comes over here and is cited directly over here. And so that is some of the ideas or the features and functionalities behind citations. There's one thing to call out, is quite a few things in the scientific Python ecosystem are collaborations. And so if you are referencing a collaboration like the Tesseract team, in this case, put it in these double braces, and that just stops the name parsing. Otherwise, it would be like team et al. And this actually ensures that shows up as the Terra Desert team. There is a lot of support this year for code blocks and captions and syntax highlighting both in the LaTeX templates and the MyST Markdown templates. And so this can show the code quite simply. And so if you've ever used code inside of a GitHub comment, this is exactly the same syntax. If you want to start turning things like line numbers on, you can do that directly in there. And then once you have line numbers on, you can start to change the start of that line number or emphasize the various lines directly. Awesome. There is a question of, can MyST Markdown be edited with Emacs and Vim? And it absolutely can. There is, I think there is, because it's Markdown, any sort of Markdown accelerators in those text editors can work out of the box. I think there's likely limited support on some of the additional pieces of when we're like sort of moving into these directives. If you're using VSCode, for example, there are accelerations for this, and it gives you some of the ideas on the arguments that are possible to pass into the directives, and gives you some documentation as you're working in VS Code, for example. And so there's support in there. And then if you go to mystmd.org as well, and go to the Getting Started space and looking at these Quickstart tutorials, you can also look at how to author this content directly in Jupyter Lab, and there's some video webinars and tutorials that are also sort of ways to get up and running directly in Jupyter if you're curious about that. And that has all sorts of other ways of working. I think this one's going to be a little bit less useful in the context of SciPy proceedings, because we are asking for those LaTeX or Markdown files. But that is a different way of working in the MyST ecosystem. Awesome. Okay, cool. Okay, Python packages already have documentation, so I'm wondering, what is the balance of reproducing those in papers? I think the purpose of the SciPy proceedings is to capture the state of the art at the time. And so if you feel like there's parts of your Python documentation that should be captured in a DOI'd archived paper, then you should absolutely include it. If there are ways that you want to interact with the Sphinx Python documentation ecosystem, MystMD also has ways to do that. And so if we go into authoring external references and look at the referencing external Sphinx documentation, and it's possible that the Python packages that you're talking about may be written in Sphinx, there are ways to bring those references in and then directly reference, for example, the Python interpreter or the Python 3 documentation. This can be referenced using Markdown link syntax in this way. And so maybe I'll drop that link into the chat. And so there's a lot of documentation in that as well. And so that's maybe a little bit of a heuristic guidelines on if you're wanting to show something that's new or novel about the package that you're developing and bring that into the conversation, absolutely include it. If you're referencing external documentation, feel free to use those external references. Fantastic. Okay, there's a couple other pieces on the math side of things. You can have, again, any sort of LaTeX math included in here. And then if you are going to label that math, you can use the directive syntax of have this colon label colon, and then the label that you're giving it. And then you can refer back to that equation using one of these things called a role. And again, there's links out to the documentation that you can go to and look into the documentation for ways to cross-reference between figures and equations and sections and the different ways to do that. And if you are coming from the Sphinx ecosystem in RST, things like ref and numref and EQ and doc are also supported out of the box as well. And so that should be quite similar to how you may have worked in the past. And again, in this place, hovering over the equations will show you that content directly. There is support for footnotes. Again, hover references. These sorts of figures can be included directly. And there are some ways to label those such that you can have things like figure 1A and have that all included in the link. And then lots of different ways to do tabular content, both in sort of very simple ways of working in terms of these list tables, as well as more complex HTML parsing if you're getting like into very complex ways of working. And then there's also ways, because MyST understands LaTeX, you can include raw LaTeX directly in MyST, and that will be parsed directly. And so long table, tabular environments, and table X are all understood by MyST, and those are the main ways of how people do tabular environments in LaTeX. And so that is a top to bottom walkthrough of this of the template. And so hopefully this is quite easy to get started. Pip install MystMD, and then you're off to the races by copying this file. Again, go into the MystYAML. The big thing before you make your pull request is to change this ID to match the folder name that you've copied into. Make all of your changes inside of that copied folder and open the pull request as normal to the SciPy 2024 repository. So I will stop there, and we have about 5 minutes left, and I'm happy to stay on longer if anyone else has further questions. And yeah, I'm very excited for everybody's proceeding submission this year, and please don't hesitate to reach out to any of the editorial team